Well, hi there. So in this video, we're going to go a little bit more in depth with our discussion of fiscal policy and try to answer the question of how much fiscal change should we actually do? In other words, if we're talking about changing government spending, taxes, and transfers, how much do we need to change those things by in order to correct an output gap? So let's get started. Okay, so the first thing to understand is actually not really necessarily about on these problems here. It's just think about the kind of context of what we're discussing this for, the purpose of what we're trying to do with all of this. Imagine that the economy is below full employment. So we've got a little picture here of Y and PL, and we are in a recession, right? And it's a bummer. And let's say that we have a Y1 and we have a YF, and let's say that Y1 is 8 and YF is 10. And so the size of the gap equals 2, right? And we could even say like 800 and $1 trillion, 800 billion and $1 trillion. So then the gap would be 200 billion. If we were the government and we were to come along and cut taxes by, in this case, 2, or if we were to increase government spending by 2, it's going to way overshoot how much we actually need to increase aggregate demand by. Our goal is to get aggregate demand to go back to full employment output. And so we need to close a gap of 2. But what we find in practice is that if the government were to just spend 2 or cut taxes by 2, that's going to be way too much economic activity. And in fact, our aggregate demand curve would not just shift to full employment, it would push us into an expansion way beyond where we wanted to be. We got to learn to walk before we can run. We're going to learn to crawl before we can walk. And we're going to come back and talk about how would we well design that and why does that phenomena occur in just a few moments. Before we get there, we have to talk about some basic terms. Household income is what we'd say is the earned income from selling your factors, land, labor, and capital. Wages, rent, interest, and profit would be the income side. When we talk about income, the total amount of income we'd take and then subtract any taxes that people pay, add any transfers that they receive, and then we get something called disposable income, or DI. Disposable income can only be done with, or you can only do 2 things with disposable income. There's only 2 ways you can dispose of it. You can consume, which we would say is C, or you can save, which we're going to say is S. You can either consume or you can save, nothing else. Now, if we said that, for example, we spent 2, right? And let's imagine that we overshot the goal. Let me talk you through why this would be an issue. If we were to increase government spending by 2, that would put 2 into, say, your pocket. Let's say you, my viewer right now, I hire you to build a bridge for the government, and I pay you 2. Well, the initial event would be plus 2, and that would be government spending. But then you would go and actually spend some proportion of that. Let's say that you spend 75%. That's how much you consume of your disposable income. So you would go and consume 1.5 more at someone's store. And then the person whose store gets the 1.5, they're going to actually go and spend 75% because that percentage of consumption, we're going to say, applies to the entire country. And so 75% of 1.5, well, that means they're going to be spending, I don't know, what is that? 1.0? No, 1.5, 1. Yeah, it's about 1, right? A little bit more. And then the next of that, a little bit more, right? 0.75 consumption. And then a little bit more of that would be like 0.57 consumption. We would have all this added consumption that would occur. And if we started with 2 in government spending, and we said there was a 75% was consumed, then in fact, the total amount would be 8. It would overall increase by 8. So it's a fairly quick process, actually, that I could do that with, that I could jump from 2 to 8, but it occurs because one person's spending is another person's income. So in other words, if the size of the gap were 2 and we spent $2 in government spending, we're going to get so much more multiplied effect in the overall economy that we would well overshoot that 10 as our full employment output. We would have 8 extra added to our GDP for a total of 16 way beyond. So we actually need to think about it maybe more like this. Think about the metaphor of if I took a rock and I threw it into a pond and then it goes kaploosh. That initial event is the 2 that gets added to GDP. But then every ripple in the pond gets added to GDP as well through more consumption. And so I have to be very careful when I actually design the size of the initial rock that I throw into the pond. And that's where we're actually going with all of this. Now, in order to figure out the size of the rock that I should throw into the pond to get this to be the right number, I have to also take something with this proportion that I consume and that I save. What we would refer to as the 75% that's consumed, we call that as your marginal propensity to consume. Marginal is additional, propensity is likelihood. It's your additional likelihood to consume. And it's really the fraction spent of any change in disposable income. So if I gave you an additional $1,000 of income, you spent 75%. That means you spend $750 of the 1,000. 750 divided by 1,000 is 0.75, so that would be your marginal propensity to consume. Your marginal propensity to save is just whatever the proportion was that you saved. So in this case, you would save 25%. If I gave you an extra $1,000 of disposable income, you're saving 250. 250 divided by 1,000 is 0.25, so your MPS would be 0.25. Now let's go ahead and see if we can calculate what these MPCs and MPSs would be given a table of consumption, saving, and disposable income. The first one's done for us. So if I change income by 1,000, I change consumption by 900. 900 over 1,000 is 0.9. If I change income by 1,000 and I change savings by 100, it goes from negative 100 to 0, then that's 100 over 1,000, which is 0.1. That's done for us. Let's do the next one. If I change my income again by 1,000, it goes up 1,000 more. Now I consumed 800. 800 over 1,000 is 0.8. Now I've also changed my income by 1,000, but I changed my savings by 200. 200 over 1,000 is 0.2. Now the next one, 1,000 change in income, change in consumption of 700 means that this one would be 0.7, 700 over 1,000. But my change in savings was 300. 300 over 1,000 is 0.3. The last one, or the last two, 1,000 is my change in income. My change in consumption goes up here by 600, right? That's 600. And so 600 over 1,000 is 0.6. That makes this one 0.4. And the last one, my income goes up by 1,000. My consumption goes up by 500, so 0.5. And then this one's 0.5. A quick question for you. Why would the sum of these two numbers always equal 1? Think about it for a second. Why would that have to be? Well, because disposable income, you can only consume and save. Can only consume or save disposable income. There's only two choices. And so as a result, they would sum to 100%. Now we can take these numbers that we've just calculated, the MPSs, and actually we're going to do something with that to convert those into what are called multipliers. So if we had a change in investment or government spending, we're going to use the spending multiplier, hence the name. So this is true for both investment spending and for government spending, changes in I and changes in G. The spending multiplier is 1 over the MPS. And it's a good idea maybe just to rewrite it here, just so you have it in your head somewhere. Spending multiplier is 1 over the MPS. And let's see what it would look like with a practice problem. Well, here it gives us that we have an initial change in investment or government spending equals times the multiplier equals the total. If government spends 100 billion on a bridge, so there's 100 more in G, and the MPS is 0.1. Well, the spending multiplier equals 1 over 0.1. That's equal to 10. So I take 100 multiplied by 10, and I find that the overall increase is 1,000. It's just the total amount of increase. And let's see if we can actually do that using this one up here for a hot second. Well, the initial amount was 0.2. That makes our MPS 0.25. Our spending multiplier was 4. 2 times 4 was 8. So that's actually how I did that, and I just did it in my head. As I said, if we're consuming 75%, our MPS is 0.25, and that makes our spending multiplier 4. 4 times 2 is 8. Let's take a look now at the bottom. The last example is taxes and transfers, and there are two tricky parts with taxes and transfers. The first is to know that the taxes and transfers multiplier is not the same as the spending multiplier. There's a different name. They use different contexts, right? I don't know how else to put that. You use the spending multiplier when you're talking about spending. You use the taxes and transfers multiplier when you're talking about changes in taxes and transfers. And the tricky part maybe with that is to know that taxes and transfers don't directly affect output. In other words, if I give you a tax cut of $2, the $2 doesn't change GDP at all. It only would change GDP after you decide to consume. So in other words, with this very first event that we talked about up here, if this 2 wasn't a change in government spending, but instead a tax cut, Well, you're still going to spend 75% more. This round of 1.5 will still occur, but the 2 doesn't count. And so this multiplier is a little less as a result. And it's pretty simple. It's 1 less than actually what your spending multiplier was. So if your spending multiplier was 10, we would say that your taxes and transfers multiplier was 9. Now, if the government were to, let's see if we understand it, raise taxes by $100 billion, so we'd say increase tax by 100 billion. Now we have an MPS of 0.1. So the spending multiplier is equal to 10. Therefore, the taxes and transfers multiplier is equal to 9. How did I know that was 10? Well, because we just did it. Right? So sometimes I have people ask them, like, we just did that one. Now, if I know that this is times 9, that's going to produce a change in GDP of 900. But I said there were 2 tricky things about the taxes and transfers multiplier. The second tricky thing is note increases and decreases. If you have higher taxes, that's going to cause overall output to go down because people are going to have less consumption spending, right? Careful with up and down. We'll put that right there. Hopefully you remember to do that. Let's do another one. If government provides 100 billion in transfers, so they increase transfers, and I'm writing them kind of this way to help you remember that we got to be careful with these ups and downs. Times 100, of 100, right? So that's really just increase the transfers by 100. My MPS now is 0.25. So that makes my spending multiplier 1 over 0.25. That's equal to 4. So my taxes and transfers multiplier is equal to 3, right? Just 1 less. Now we do times 3. That's going to equal a change in output of 300. But is it going to be more or less? Well, this time the government's providing money, so we'd say there'd be an increase in output overall. Careful then with these ups and downs. It's different for taxes and transfers, right? When the government takes your money versus gives you money. But I think that you can understand these using the context of the problem. Hopefully this helps you understanding a little bit about the use of the multipliers. When we get into some practice with them, it's going to make even more sense. I'll see you next time.